Record. Okay, this is a review for the AP Calculus AB final for the year 2022. And you guys, with spring football starting, I've been so pressed for time. So I just kind of went through the reviews that we've already used this semester and kind of picked the key concepts that I want to put on your final. All right, and so I haven't had a chance to go over any of this. So I'm opening up the review presentations that I haven't seen since we did the reviews. So we'll just do our best and flow through this, okay? I also have classes going on right now. This is algebra, and they're working on the review for their final. So if there's a few interruptions, I hope you guys understand. Let's make sure we have this down. Okay, so here's the first type of problem you're going to have to be able to do on a final exam, where they've given you the definite integral from 4 to 10 of f of x dx is pi. From 8 to 10, that integral is pi over 6. And now they want us to find the integral from 10 to 8 of f of x dx. So do you notice that all they did was they reversed the bounds, 8 to 10 and 10 to 8? So isn't that simply going to give me a negative pi over 6 right here? All right, now look at this one, 10 to 10. Well, remember, that interval gives me the base of an area of a region under a curve. So I don't have any base right here, so this would have to be a 0. All right, and now 4 to 8 of f of x dx. Well, I have 4 to 10 right here, and I have 8 to 10 right there. So let's think about this then. If 4 to 10 is pi, and 8 to 10 is pi over 6, wouldn't 4 to 8 be pi minus that pi over 6? Which would be 6 pi over 6 minus pi over 6. That's a 5 pi over 6. All right? So that's just, do you understand what definite integrals really mean? Pretty simple stuff there. All right. Now, find the average value of f of x equals 1 over x on the closed interval from 1 to 4. So you need to remember your formula for the average value of any function. And that's calculus. It's nothing more than what? 1 over b minus a on the outside, and then you take the integral of your function with respect to x from a to b. Okay, so let's put this together. What's b minus a? Well, that'd be 4 minus 1 is a 3. And then what do you have here? From 1 to 4 of f of x, which is 1 over x dx. There it is right there. All right. So what is the antiderivative of 1 over... Oh, I'm going to write this as x to the negative 1, aren't I? Okay, and then I can just use the power rule right here. Okay, so what is the antiderivative of x to the negative 1? Wouldn't that be x to the 0 over 0? That doesn't work, right? So what do I got to do? X to the 0 over 0? Well, I got to remember that the antiderivative of 1 over x is the natural log of the absolute value of x, but if I look my bounds, I don't need that absolute value right there. So, this is power rule 2 right here, so 1 to 4 right there. So here we go. I said power rule, I meant I'm going to do the definite integral here. So I see a 1/3 natural log of 4 minus natural log of 1. And if I visualize the natural log, isn't the natural log of 1 going to be a 0? So this looks like my final answer I would write as 1/3 the natural log of 4. Okay? Am I going to write it in a bunch of different ways too? I am here, but they're all the same answer and all very appropriate. Okay. I'm checking it too, apparently. And that's going to be a 0.462 right there. Okay. Oh, I just double-checked those answers, didn't I, on my calculator? Very cool. Okay. Evaluate the integral x squared root x cubed plus 3 is the integrand differential of x. So this looks like substitution to me. And I think you guys would use a u of x to the 3rd plus 3, making your differential of u, what, 3x squared dx? All right, let's do our substitution and see what we get here. So do you have a u to the 1/2 and then a differential of u, all right? And that differential of u looks like it gave me the factor of x squared, it gave me the differential of x, but it gave me an extra factor of 3 that I've got to undo with a 1/3. All right, so now I'm 1/3, and what's the antiderivative of u to the 1/2? That'd be u to the 3/2 over 3/2. So u to the 3/2 over 3/2 would be 2/3 u to the 3/2 plus c. Let's clean that up. So 1/3 of 2/3 would be 2/9. Okay, and then what's my u? X cubed plus 3 to the 3/2 plus c. And there's number 6. All right. Now, use the average of R sub 4 and L sub 4, the trap rule, to approximate the area of the region bounded by the graphs of y equals sine of x and y equals 0 on the interval from 0 to pi. Well, let's look at those graphs right here. So delta x, well, let's see. Think about this. My b is pi, my a is 0, and I have a 4 subintervals, so my n is going to be a 4. So isn't that going to be a pi over 4? There it is right there. B minus delta x is always b minus a over n. Okay, so the trap rule. Well, let's think about this a second. All right. Isn't my formula going to be what? 1/2 delta x? I think I'm going to have a pi over 8 out here. Did I not write down the formula? Okay, hang on here. What's going on here? Oh, I'm using the average of R sub 4 and L sub 4, so I'm not really using the trap rule here. Okay, gotcha. So I've got to go pi over 4 and then f of, and I'm using my right endpoints first. All right, so that would be, let me see. I'm starting at 0. I got a pi over 4. I've got a pi over 2. I've got a 3 pi over 4, and then I get to the pi right there. And now that right there. Well, we can do this probably without a calculator too now, can't we? So L sub 4 is going to be pi over 4, but now I'm using the left endpoint, so that's going to be a 0, a pi over 4, a pi over 2, and then a 3 pi over 4. Now, if I can get both of those, I can find my average, which is the equivalent of a trap rule. So R sub 4 equals pi over 4, all right? And what is sine of pi over 4? Well, that'd be a root 2 over 2. What is sine of pi over 2? That would be a 1. What is sine of 3 pi over 4? That'd be another root 2 over 2. And what is sine of pi? That would be a 0. So let's clean that up. And, oh, I just went right to it, okay? So do you see a pi over 4 and then a 1 plus root 2? And there's R sub 4 right there. This is going to jump in here every once in a while. I'm so sorry, you guys. All right, go away for a while. Now let's find that L sub 4. So I'm going to go f of 0 would be sine of 0. And sine of 0 is what? A 0. And then f of pi over 4, that'd be a root 2 over 2, sine of pi over 4. And then sine of pi over 2 is a 1. And then sine of 3 pi over 4 is another root 2 over 2. And do I have exactly the same thing? I think I might. Yeah, look at that. So if I find the average of those two, I'm going to end up with pi over 4 times the quantity, 1 plus root 2. And there's my final answer. Very cool problem. Okay, number 11. Now, I'm going to count on you being able to do this on your calculator, whether or not you have a newer calculator or an older calculator. And if you need some help on this, you let me know. Now, there is also some formulas, so you can do this without a calculator. And I don't know if I went there here. Let's find out. No, I'm going straight to my new calculator right here, which is just fill in the blanks. So here I got to go. An x equals 1. My upper bound is 5. And I punch that out in terms of x's now. And my calculator will do this for me right now. Now, if you have an older calculator, please let me know, and I'll show you how to do this on your older calculator. And did I have you do this by hand at all? Doesn't look like I did. Okay, now we're going to evaluate an integral where my integrand is a polynomial. So I just need power rule here. So, heck, hang on, am I skipping all kinds of steps here? Let's see. All right, so I've got the antiderivative of 2x to the third is x to the 4 over 4 times 2. that would be an x to the 4 over 2. And the antiderivative of x would be x squared over 2. And the antiderivative of negative 1 is going to be a negative x. And now don't forget your plus c. All right, going pretty good. Find the particular solution of f prime of x equals 2x to the negative 3 halves, satisfying the condition that f of 4 equals 6. So this was your first introduction to differential equations right here. So you know you need the antiderivative of this derivative to find your original solution f of x. So f of x would be the antiderivative of, let's bring the 2 out front, and then I have an x to the negative 3 halves dx. Okay, so let's find that first. So I've got the 2 out front still, and that would be an x to the 1 half divided by 1 half or times 2. Oh, did I forget? Divided by, let me see, I lost the negative there. Let's be careful, Gibbons. Okay, so that's going to be divided by negative 1 half, which is times negative 2 right there. All right, and now plus c, and we can simplify that and use our condition that they gave us to find the c. So let's see here. How about we got negative 4 over root x, or x to the 1 half in the divisor, plus c, and now let's use this f of 4 equals 6. So f of 4 equals 6 implies negative 4 over the square root of 4 plus c has to equal 6. So that's a negative 2 plus c equals 6. So it looks like c equals 8. Yep. All right. So let's put that in here. So f of x equals negative 4 over root x plus my c, which is 8. Okay, guys, we got to keep it down a little bit more. This is a really important video, you guys. Okay, can you do that for me? Thank you. Also, I'm crunching a bunch of numbers, and if I get distracted, I'm going to screw up on a video, and that's really embarrassing. Thank you, you guys. Sorry, guys. Let's keep going here. All right. This looks like a simple substitution right here. So would you guys go u equals x cubed plus 1? And then the differential of u would be 3x squared. And don't forget your differential of x. So let's do our substitution, including our bounds. I'm going to write my bounds in terms of u too. So if x is 0, u would be a 1. And if x is 1, u would be a 2. And then I'm going to go a u to the third and a differential of u. And you see that extra factor of 3 right there? So undo that with a 1/3. All right, let's do a little calculus now here. Is the antiderivative of u to the third u to the 4 over 4? Okay, from 1 to 2. And we could even clean that up a little bit if we wanted to. Let's see if I did. Yeah, it looks like I brought the divisor of 4 out to get a 1/12. And then u to the 4 would be 2 to the 4, and that's 16. And then a 1 to the 4 would be a 1. So I see a 15 over 12, which I'm probably going to reduce. Malcolm would leave that alone right now, but let's say this is free response. We got to be able to reduce our fractions right here. And doesn't 3 go into each of those? What would that be, a 5 over 4? There you go. All right, now another substitution, but this time the u is going to be x over 6, which makes our differential of u 1/6 dx. Okay, let's do it. So I've got cosine of my u. I've got my differential of u, which gives me the differential of x, but that extra factor of 1 over 6 that I've got to undo with a 6. There it is right there. Now let's keep going. So I've got 6 times. And what is the antiderivative of cosine? Isn't that a sine? Sine of u. And then I got a plus c here. So let's finish this. 6 sine of what was u? X over 6 plus c. Okay, number 11. 8x minus 10, and g of x is x squared minus 4x plus 10. And we need to find the points of intersection. So I'm going to set the linear equal to the quadratic and solve for x. See if that's what I did. Yep, so 8x minus 10 equals x squared minus 4x plus 10. Okay, and then let's put this in quadratic form. So I'll go 0 on the left, and x squared minus 12x plus 20. I hope that's factorable. Zero product property of algebra. Factor x and x. And I need a product of 20 and a sum of negative 12. So I know that's going to be a minus, minus, and what? 12. Would that be a 10 and a 2? I think so. How about a minus 10 and a minus 2? There you go. And now by the zero product property of algebra, x either equals 10 or 2. So I've got my x coordinates. I could plug those into my f of x to find my corresponding y coordinates here. So if x is 2, that would be 16 minus 10. That would be a 6. And if x is 10, that would be 80 minus 10. Ooh, that's a 70. Okay, there's my intersection points. Oh, that's obviously why I did not scale that. Just a second, I got a phone call here. Mr. Gibbons. Okay, thank you so much. Bye-bye. Did Frankie just leave for her appointment at 11:10? You're right here. You're getting picked up right now, Frankie. Have a great day. Be here tomorrow. And remember, I'm going over this stuff on Monday and Tuesday. Okay, guys, keep it down. A little longer. Thank you. I'm sorry these calculus videos are long, too. Way longer than you guys. Okay, well, let's scale the y-axis and plot those 2 points in the plane. That looks like that would work. So 270, that's going to be right up in here. Okay. Oh, I started with 2.6. Yeah, 2.6 is going to be right in here. And then 1070 is going to be up here. All right. And now you know a line goes through those 2 points. I bet you I did that next. Oh, yes, I did. And then I got a parabola opening downwards. All right. And I could do this perfect if I found the vertex, but I know it's parabolic shape. So, you know, let's see what I did. I'm going to find the axis so I can do it perfect. So negative b over 2a would be negative 4 over 2. That's a negative 2. Okay? So think about this. That's a positive 2. Let me see. Hang on here. Negative b. Okay, the opposite of b, that'd be 4 over 2. That's a 2. Yeah, so that is the location of my vertex. So my parabola is just going to do this. Okay, there's a great picture. So find the points of intersection. We've got that part done. And draw the region bounded by these two functions. We did that. And now we're going to compute the area. Well, isn't that just going to be my definite integral from a to b of the upper function? I can call it f of x minus my lower function, g of x, differential of x, right there. Okay, so let's put this together. So my lower bound is a 2. My upper bound is a 10. And f of x minus g of x, I might have done this right here. Upper function is linear, so that's going to be 8x minus 10. And then minus this, so I probably did minus x squared plus 4x minus 10. And now I might clean that up a little bit. Yeah, I did. And I don't know if I put it in descending order, but if I did, I would go negative x squared. Yep. And then what, 12x's, and then minus 20. Okay. So let's do a little bit of power rule right here. That's a negative x cubed over 3. And that's a 12x squared over 2, or 6x squared. And that's a negative 20x. There you go. And now let's just go f of b minus f of a. So I'm going to go negative 1,000 over 3 plus 6 times 100 plus 600. What did I do there? Oh, I bet you I'm going common denominator right here. So let's see. Yeah. So do you agree that that would be a 100 times 6? That's a 600. But I need to put it over 3, so I'm going to go 1,800. Okay, and then the last term would have been a negative 200, which is going to be negative 600 over 3. All common denominators there. I'm doing this totally by hand. Look at me. All right, now do the same thing with the 2. So I see a negative 8 over 3. And then I see a 4 times 6 is 24. But put that over 3, I'm going to go 72 over 3. And then negative 40, but I'm going to put that over 3, so I got, what, negative 120 over 3? All right, let's see if we can get this together. So I see an 800 over 3. That's a 200 over 3. Look at that. And then right here, this one's not going to be quite as easy, is it? All right. So I got the 72 minus 8. That's a 64 and 120 over 3. I got it. So I just did the arithmetic, and I'm sorry I didn't take the time. 56 over 3. And so what do I got? A 256 over 3. Cool. Next problem. Find the area of the region bounded by, oh, this is x in terms of y. All right, very cool. So I've got my x in terms of y, and I've got the quadratic function right here, and I've got the linear function right there. Okay, let's do it here. Intersection points. So there they are, all right, but I'm going to find it and make sure it's all accurate right here. So can I go y squared plus 4y minus 22 equals 3y plus 8? All right, let's solve for y. Put it in quadratic form right there. Thank you, Lainey. So I'm going to bring everything looks like over here to the left. So I got a y squared minus 3y from 4y. That'd be plus y. And negative 22 minus 8 more, negative 30. I hope that's factorable. So I got a y and a y. And a product of negative 30, but a sum of positive 1. So is that going to be a minus 5 and a plus 6? Yep. So by the zero product property of algebra, I know that my y values would have to be a negative 6 and a positive 5. Okay, cool. And I'm going to go from C to D here. And now I'm going to go what? F of D, the upper function. I should say f of y minus g of y dy. Okay. Uh-oh. Didn't mean to push that. So did we decide that our lower bound would be a negative 6? And the upper bound was a 5. All right. And now, instead of going upper to lower here, I'm going right to left here is what I'm doing. All right. So it looks like the linear is on the right. So that's going to be a 3y plus 8 minus a y squared minus a 4y and plus a 22. Now it looks like I have some terms that I can combine here. So I have a negative y squared, and I have 3y minus 4y minus y, and I have an 8. That's a 30 right there. And now I'm ready to do my power rule again. Oh, and I just did this one on the calculator, you guys. And I got 221.83 repeating, or to 3 decimal places, 221.833. Oh, I made it a fraction too, 1331 over 6. Cool. That's exact. Okay, let's keep on rolling. Oh, you guys remember this problem right here? And all I'm going to ask you to do on the test is part A. So to save time, let's focus on part A. Calculate the volume of the ramp in the figure by integrating the area of the cross sections. So perpendicular to the x-axis. So the cross sections perpendicular to the x-axis would be rectangles. And, oh, I'm going to find the area before I even do this, aren't I? Isn't that a triangular prism right there? You guys, is it time to go? 3 minutes? Okay, I'm going to finish this slide and then close up for now to start my next class. Actually, yeah, I'll do that. So V equals BH. So let's think about this thing. Wouldn't the base of this triangular prism be this right triangle, which would have an area of what, 6? And then the height of that would be a 4. 6 times 4 is 24. So that's my answer already. All right. Now let's do the rectangles right here. That's that cross section I was just talking about. Okay. So now we're going to go, and we got to go from what, 0 to 6 here? I'm doing general right here. And a of x dx. So I think we're ready. 0 to 6. And what's the area of this rectangle right here? Well, I know one dimension is going to be 4, and the other dimension is going to be the equation of this line right here. All right, so let's think about that here. There's my 4, and I'm going to call this height z right here. So I'm going to have z equal to, and there's a y-intercept of 2 there, and I see the slope 2. Is the slope, let me see, dropping 2 and running 6. Is the slope negative 1/3? There's my 2 minus 1/3 x. There it is. And there it is right here. Hey, keep it down a little longer for me, you guys. You've done great. Thank you. So let's bring that 4 out and go 2 minus 1/3. Well, it looks like I'm going antiderivative. 2x minus 1/3 x squared over 6. So minus 1/3 x squared over 6. How did I write that? X squared over 6. Good. And then I'm going to go from 0 to 6. Okay, so fundamental thermocalculus. And we have got a 4 times 12. Let's go. 12 minus 6 is a 6. Okay, right there. And then if I put 0, I'm just going to get 0. So look at what I have right here. 4 times 6, and that's 24. Had to work. There it is. Answer is 24. And I don't have to do the other 2. You guys can do it if you want, or watch or do that on your own. I guess there won't be a video. Okay, I'm going to stop this right here so I can get my calculus class started, and then we'll do the other half of this video for a second video here. Thank you very much. Stop this. 26 minutes.